Now I am going to discuss about the fluid statics. In the last session also we defined what is fluid statics and what are their properties. Okay, so when the fluid on the if a body is submerged in the fluid, that means it has forces, compressible forces, not tensile forces. Okay, compression forces will be there, so that body will be subjected to compressive force. Okay, either when the fluid is on the surface, then it will exert the pressure on that surface. Okay, that is the another aspect of the fluid statics. Now I am going to derive the Pascal's law. Okay, Pascal's law. What is Pascal's law? Let us see. It is also about the fluid statics only. Okay, suppose there is a fluid, so at particular depth, at particular point, that pressure, intensity of pressure or pressure will be equal in all the directions, whether it is in x direction or it is in y direction or it is in z direction. All intensity of pressure will be the same. That is the statement of Pascal's law. So okay, let us write like this. Statement. What is a statement? The pressure or intensity of pressure at a point in fluid statics statement is pressure or intensity of pressure at a point in fluid static is equal in all direction. Okay, that is the pressure exerts or pressure exerts equally in all directions. That is the statement. Suppose this point is there, so this will be px, this will be py, and this will be pz. So what we have to prove? Amount of px will be equal to py is equal to pz. That we have to prove. Okay, so Pascal's law states that pressure or intensity of pressure at a point, particular point, this point I am talking about in the fluid static, is equal in all three directions, or pressure exerts equally in all directions. That means at this point, this px, py, pz we have to prove equally. Okay, so let us consider how to prove. Now I am going for the heading for the proof. Consider a wedge-shaped like product. Okay, subtending at angle theta. Suppose A, B, and C. Okay, now wedge shape, this one wedge shape okay, having dimensions dx, dy, and dz. So that is dx, okay, and this is dy, and this is dz. Okay, that is wedge shaped product having the dimension of this one. Okay, now what are the pressure? Now see, let px, py, and pz be the intensity of pressure in x, y, and z direction. Okay, let width of the elemental area elemental area is unity, that means 1, that is perpendicular to the plane of the paper, Okay, so now what we have to do, see here, see this is px, x direction, this is acting at py, and this is acting at pz, okay, at angle theta, remember, and this pz like this. Now what will be the force on face AB will be equal to Px is your pressure, force means pressure into area, so dy into 1 because width is 1. Now force on face BC will be equal to, what would it will be? Py into dx into 1. Okay, and on AC it depends upon the horizontal and vertical, okay, like this. This will be Pz cos theta and this will be Pz sin theta vertically and this is horizontally. Okay, so equilibrium condition, at equilibrium condition, see now taking the force horizontally, I am taking the force horizontally. Horizontally means, see here, horizontally means AB force, that is Px into dy into 1 will be equal to opposite direction. See this one, so not like this, this will be like this, so this will be like this, it will be Pz cos theta, okay, into dz into 1. Am I right? So now from this figure, cos theta is nothing but, see here, from this ABC triangle, cos theta is b by h. So b is dy, b by cos theta is b by h. H is nothing but dz. So see, dz cos theta is nothing but dy. So dy will get cancelled, 1 will get cancelled. Okay, so that will be Px is equal to Pz. Let us call it as 1. Now vertically, if we apply the force, then it will have Py dx into 1 will be equal to this force. Now see, so this force will be Pz into sin theta into dz, okay, dimension dz into 1. Now from the same figure, here sin theta is equal to p by h. So p is dx, sin theta is equal to p by h, h is dz. So sin theta into dz, see, sin theta into dz is dx, okay. So this is dx, this dx will get cancelled, 1 will get cancelled. So py is equal to pz. Now see equation 1 and 2, px is equal to pz and this pz is equal to py. So therefore px is equal to py is equal to pz. This proves the Pascal's law. Statement was pressure or intensity of pressure at a point in fluid static is equal in all three directions. That we have proved from taking the account of this one. Okay, thank you. Rest of the thing I will discuss in next class.